Hello and welcome to BYJU'S. In this session, we'll discuss the tropical cyclones of 2018 and 19 season, and more specifically, the tropical cyclones of North Indian Ocean. And these are also very significant in prelims point of view. Tropical cyclones are the low pressure systems, that is, the irregular wind which acquires the rotation motion around the low pressure center. Such winds are referred as the cyclonic winds. And the atmospheric disturbances are responsible for the circular motion. And these winds, they rotate in anti-clockwise direction in the northern hemisphere, and they rotate in the clockwise direction in the southern hemisphere. And these low pressure systems, or the cyclones, they are named differently. In case of Indian Oceans, more specifically in Bay of Bengal and the Arabian Sea, they are referred as cyclones. And in case of the Pacific Oceans, they are referred as the hurricanes. Now, the ideal condition for the formation of the tropical cyclones. So these tropical cyclones are found in between the tropics, that is Tropic of Cancer and Tropic of Capricorn. And as the temperature is a dominant factor, so these cyclones are also referred as thermal in origin. And in case of tropics, there is a dominance of the trade winds. And trade winds, they blow from eastern side towards the west. So that's why in the tropical areas, more specifically in the oceans or the large water bodies, the western margins are more warmer. So because of this, the tropical cyclones originates in the oceans, and that too the western margins in the tropical area. Second one is the weak vertical wind shear. So when there is weak wind shear is there, the air raises up. So when the air raises up, it is responsible for formation of the cyclones. And this wind shear or less wind shear is responsible for creating the vorticity due to the Coriolis force. The third one is the moisture. Abundant moisture is needed for the formation of the tropical cyclones, and these moistures provides what we call it as the latent energy or the latent heat. And this moisture is maximum on the surface of oceans. So that's why these tropical cyclones originates on the surface of oceans. Then the last one is the Coriolis force. The Coriolis force, when we talk at the equator, it is 0, and it increases as we move towards the poles. And this Coriolis force is associated with the deflection. And because of the impact of Coriolis force, the wind acquires the vorticity. That is, the vertical wind acquires vorticity or the rotation. And this rotation is anti-clockwise in the northern hemisphere and clockwise in the southern hemisphere. So this Coriolis force provides the rotation to the wind. So as it is 0 at the equator, so we find the tropical cyclones originates just near to the equator, that is near to intertropical convergence zones. And no cyclones or very less amount of cyclones are formed exactly on the equator. And once the tropical cyclone is formed, then it has a path or orientation which is parabolic in nature. That is, it moves from east to west along the axis parallel to equator. After that, it moves to the north, then in the northeast. So it acquires a parabolic path. In case of North Indian Ocean, Indian Meteorological Department, more specifically, classifies these cyclones in India into different categories on the basis of the depressions or the wind which is acquired. Because as these tropical cyclones are compact, the pressure gradient is very high, so the wind velocity is also very high. So that makes the tropical cyclones more intensive. So these characteristics are used to define the categories of the cyclones in case of India. If any depression which is less than 62 kilometers, it is referred as the depressions or cyclonic depression. If the wind velocity is more than 62 kilometers, then it is referred as the cyclone or the tropical cyclones. If it is exceeding more than 222 kilometers per hour, then such type of pressure gradient or winds are referred as the super cyclones. And in between these, the cyclones are classified as the severe cyclones or extreme severe cyclones on the basis of the wind velocities per hour. Now the next is the naming up of the tropical cyclones. The tropical cyclones are named, one, to make ease of communication between forecaster and the common people. Second one is, these tropical cyclones, average life of this tropical cyclone is around 4 to 7 days. And these tropical cyclones, sometimes in a single basin, more than 2 cyclones originates. So to avoid the confusion between one cyclone to another cyclones, the naming up of the tropical cyclone is done. And the names should be short and easy to communicate. And in case of North Indian Ocean, the 8 contributing countries are Bangladesh, India, Maldives, Myanmar, Oman, Pakistan, Sri Lanka, and Thailand. And these countries, they have provided 8 names. So totally 8 into 8, 64 names are there. And these countries are arranged on the basis of alphabetical orders. And the names are provided on the basis of countries arranging on the alphabetical order and the proposed names. So in the year 2018 and 19 season, the first cyclone was SAGAR, after that MEKUNU, then DAYE, then LUBAN, TITLI, or GAJA, then PETHAI, and in the year 2019, at present when we talk about the FANI cyclone. So this is how the cycle moves. And after this FANI, the next cyclone which originates in the North Indian Ocean, either in Bay of Bengal or in the Arabian Sea, will be referred as Vayu, then it will be Hika, then Khirab. So this is how the naming up of the tropical cyclones is done. Now the first cyclone of 2018 and 19 is the cyclone SAGAR. The cyclone forms on the surface of ocean, and after that it traverses and enters on the land or the continent. The moment when the cyclone enters on the land, that phase is referred as the landfall of the cyclone. And in case of the cyclone SAGAR, the name SAGAR was proposed by India, and it made landfall on May 19, 2018, and the landfall was near Djibouti, that is Somaliland and Djibouti. So here the landfall of the cyclone SAGAR was done. This was very significant because rarely we find the cyclone enters into the Gulf of Aden. And this cyclone, which originated in the Arabian Sea, after getting matured, it enters into the Gulf of Aden and made a landfall in this area. So very rare cyclones enter into the Gulf of Aden. So apart from this, in the year 2015, we find Meg cyclone and the Chapala cyclone have also made a landfall in Gulf of Aden. So this is the rarest case regarding the tropical cyclone SAGAR. The second cyclone of the season is MEKUNU, named by Maldives, and it made landfall on May 25, 2018 near the city called as Salalah of Oman. And this was originated in again Arabian Sea. It traversed from here and made a landfall somewhere here in Oman near the city called as the Salalah. And the third cyclone is the cyclone DAYE. Name was proposed by Myanmar, and it made a landfall on 21st September 2018, and the landfall was near Gopalpur in the state of Odisha. So this cyclone originated in Bay of Bengal, and this is a region where it made the landfall. And this region, that is Gopalpur in the Odisha, is in the south of the Chilka Lake. So this small enclosure is a Chilka Lake. This is the largest lagoon in India. The next cyclone is the cyclone LUBAN, and it was named by Oman. It made a landfall on 14th October 2018, and the landfall was in Yemen near the Oman, and this cyclone was developed in Arabian Sea. The next cyclone is cyclone TITLI, named by Pakistan. It made a landfall on October 11, 2018 near Palsa of Srikakulam district of Andhra Pradesh. So here we find Srikakulam district of Andhra Pradesh, and in this region it made a landfall. And this cyclone TITLI originated in Bay of Bengal. Now, a unique phenomenon and the rarest of the phenomenon was found during the formation of TITLI and the LUBAN. So these two cyclones, that is TITLI and LUBAN, are very unique cyclones. Both are severe category cyclones, and both the cyclones formed in either side of the Indian mainland at the same time. So here we find the formation of TITLI, and in the Arabian Sea water we find the formation of LUBAN. This TITLI made a landfall in the Srikakulam district near Andhra Pradesh, and LUBAN entered the Arabian Peninsula. So this is a rarest phenomenon which has occurred, where the two cyclones are formed in the two sides of the mainland of India, Bay of Bengal and the Arabian Sea. Remember, it is LUBAN and TITLI. Now the next tropical cyclone is cyclone GAJA, and this was named by Sri Lanka, and this made landfall on November 16, 2018, and the landfall was then in between Nagapattinam and Vedaraniyam of Tamil Nadu. So in this region near Nagapattinam, the cyclone GAJA made a landfall, and this cyclone GAJA was originated in Bay of Bengal. And the next cyclone is the cyclone PETHAI. It is named by Thailand, and it made landfall on December 17, 2018 in a region called as Kathrenikona of East Godavari district of Andhra Pradesh. So here we find the East Godavari district. So in this region the cyclone PETHAI made a landfall, and this cyclone PETHAI again originated in Bay of Bengal. And the next cyclone in the series is the cyclone FANI, and it is named by Bangladesh, and it made landfall on May 3, 2019 near Puri, which is in the north of Chilka Lake. In Odisha. So here it made a landfall, and here we find the Chilka Lake, which is in the south of the landfall region. Now the unique things about the FANI is, one is regarding its trajectory. Usually the tropical cyclones follows the parabolic path. And here, instead of parabolic path, initially it started its orientation, and after reaching near the Tamil Nadu region, it changed its trajectory and started moving upward. That is toward north. That is towards the northern part near Odisha, and it was a straight path which moved in that direction. Second important thing is regarding its intensity. It stayed for around 10 days on the surface of Bay of Bengal. Usually the tropical cyclones have a life of 4 to 7 days. So this cyclone stayed for 10 days. So because of which it gained more amount of moisture, the latent energy. So that's why it became a severe cyclone. Initially it started with the depression. Then the moment when it reached to the landfall area near Odisha, it gained huge amount of the moisture and latent heat, and that's why it became a very severe cyclone, extreme severe cyclone, which made a landfall in this region. After this tropical cyclone Fani, the next tropical cyclone will be Vayu, and this is named by India. Usually when we see the share of tropical cyclones in a season is generally more in Bay of Bengal than the Arabian Sea. The reason is Bay of Bengal is comparatively warm, and also the cyclones which are developed in the west side of the Pacific Ocean, after making a landfall, they enter into Indian Ocean in Bay of Bengal and they re-intensify and develop into cyclones. So it means that in case of Bay of Bengal, the in situ cyclones are more because of the temperature factor, and ex situ cyclones which have traversed or which have traveled from the West Pacific Ocean after making landfall intensifies and increases the number of cyclones in the Bay of Bengal. But in some rarest cases, we find that the share of the Arabian Sea increases. So that's why the tropical cyclones increases in the Arabian Sea in particular seasons. And many factors are given for that. Among those, the first one is the Madden-Julian oscillation. It is also referred as MJO. So this Madden-Julian oscillation is a pulse of the pressure, clouds, precipitation, which keeps on moving. So it is a traversing phenomenon which keeps on moving in the tropical areas from the east towards the west. And it consists of two phases. In the first phase, where the ascent of wind takes place, is a region where we find low pressure is there. And the second phase, where we find the descent is there, where high pressure is created. And this phase where the ascent is there is referred as an active phase, which is associated with heavy precipitation. And this is a phase which is also associated with increasing amount of the formation of cyclones because of the low pressure here. So the active phase is responsible for creating the tropical cyclones. And in the year 2018, the active phase of Madden-Julian oscillation was there in the Arabian Sea, which was responsible for the formation of the cyclone SAGAR and MEKUNU in the Arabian Sea. And the second one is the El Nino Modoki. And this is something which we call it as a teleconnection. In general, when we talk about the pressure gradients in the Pacific Ocean, either the east coast is warm or either the west coast is warm, either of that. So when we talk about the pressure perspective, if the eastern coast is warmer, then we refer it as an El Nino. And if the eastern coast is having less temperature or high pressure, then the water will be cold here. So that phenomenon, we call it as a Peru current, or it is also called as La Nina. It means that when Peru current becomes much more colder, we refer it as La Nina phase. So in this case, high pressure is developed in the eastern side of the Pacific Ocean and low pressure is there in the western side of Pacific Ocean. So this variation is responsible for developing what we call it as the Walker cell. that is horizontal movement, vertical movement, horizontal and vertical movement. So this we call it as the Walker cell. So it may be normal Walker cell when there is a Peru current which is cold, or when the Peru current becomes much more colder, which we call it as La Nina. Now when the Peru current becomes warmer, we refer it as an El Nino, and in this case the Walker cell reverses. This is a general phenomenon which is seen. Now because of anthropogenic factors and atmospheric and ocean interferences plus anthropogenic factors, we find that the central portion of the Pacific Ocean creates low pressure. It means increases the temperature in the central portion, which becomes warmer, and both the extreme areas becomes cold, or they develop the high pressure. And we know that wind always moves from high pressure to low pressure. So in this case, the wind moves from east coast of Pacific and west coast of Pacific, and they meet at the center. They raises at the center, and they provide huge precipitation at the central part of Pacific. So in this case, the Walker cell is broken into two, one in the east side and the one in the west side. So these broken cycle cells are referred as El Nino Modoki. So in general, when El Nino is there, it suppresses the formation of cyclones. But during El Nino Modoki, when we talk, this is responsible for making strong movement of the wind downward in the west side of the Pacific Ocean or near the Bay of Bengal. So this descent of a wind creates strong diversion, and this strong diversion is responsible for reducing the vorticity. That means here no conversions of the wind takes place. So when there is no conversions, so in this phase, when there is an El Nino Modoki year, so during this special year, the number of cyclones in Bay of Bengal decreases. But at the same time, it is responsible for increasing the number of cyclones in the Arabian Sea. So we can say that this El Nino Modoki phase or El Nino Modoki year is very significant in case of cyclone formation in the North Indian Ocean. During this phase, we find the number of cyclones increases in the Arabian Sea and decreases in the Bay of Bengal. And apart from that, the third factor is also given, which is referred as the positive Indian Ocean dipole. So in general, when we talk about the Indian Ocean, we find the Bay of Bengal and Arabian Sea on the extreme sides of that, which are referred as the dipoles of Indian Ocean. And usually Bay of Bengal is warm and the Arabian Sea is cold in general. Now because of atmospheric and ocean interferences, sometimes this Arabian Sea becomes more warmer than the Bay of Bengal. So this phase when the Arabian Sea becomes more warmer is referred as positive Indian Ocean dipole. And this creates a low pressure, and here the wind moves and the convection takes place, the wind raises up, and this becomes conducive for formation of the tropical cyclones in the Arabian Sea. So in three conditions, that is MGO, El Nino Modoki and positive Indian Ocean dipole, we find the share of cyclones in the Arabian Sea increases than the Bay of Bengal. Along with that, even anthropogenic factors are also given for the increasing incidences of the cyclones in the Arabian Sea. So by this, I conclude the session. Thank you.